Okay, so we have essentially 3 lessons to cover today. First it was just 2 lessons, 15 and 16, but first hour we had so much extra time that we just did 17, get it all done in one day. And yeah, so that way tomorrow you can have time in class to work on both of your study guides, rather than having you watch a video and learn from that again. So really this lesson, because of us having so much extra time left over, because we did the 3 lessons and we still had time left over, because of that, this must be pretty easy then. So let's take a look at what we're doing today. So this isn't printed on your paper, just look at it up at the screen. It's supposed to be a notice and wonder, but rather than like giving you time to think about it and discuss, like we'll just jump right in and do it together. So like looking at this first row, these two, what form are those in that we've learned? Well, they are in function notation, that is true, but what type of function is it? Is it linear? Is it exponential? It is quadratic. What makes it quadratic?
X squared.
The x squared. That's like the most basic criteria for it being a quadratic function. Now, let me tell you, these are actually all quadratic functions. The others, if we distribute or FOIL it, whatever it multiplies out to, gives you this. So when it's fully simplified, what type of form is that? When it's fully simplified or quadratic? Standard form. All right, standard form is when you can't multiply anything out, it's all fully simplified, and it's in the form ax squared plus bx plus b. If you don't know that, maybe write down what standard form is, like what I'm writing in blue. Feel free to write maybe 1 or 2 of these examples, but there's perks to it being in standard form. One of the perks is that you can clearly see the A, B, and C of the problem, which in this unit, we're not really doing much with that yet, but like in the next unit, we for sure are. So that's the perk of it being in standard form. You can see your A, B, and C. So like in f of x, what's my A? What is in front of the x squared? If it's not written, it's implied to be a 1. This 4, is that going to be my B or my C? B, and how do you know? Because it's in front of the x to the first. So my B is 4. There's nothing else written. C is normally the single number. So if there's no single number written, then what is my C? There's no single number written in the expression. What is my C then?
0.
0. Good. So that we're more so practicing that for next unit or for something else that I'll show you today. But yeah, when it's in standard form, the advantage of that is you can clearly see the A, B, and C. Now look at the next row. These two. Oops. What type of form is it if it looks like that? Where we can do some multiplying. It is not exponential. These are all still quadratics, But this form of quadratics is known as factor form, okay? Because factors are things you can multiply, right? So if you can multiply them, like distributing that x, or FOILing these out, then those are factors, like how 2 and 3 are factors of 6, or 2 and 4 are factors of 8. If you can multiply them out, that's factor form. Now, this last one we have not learned yet, or maybe if you're in my math lab, you learned it yesterday. But this is like gonna be our main focus, is this last form, which you will see at least like 3 or 4 problems on your test on Tuesday about. So, anyone by chance know what that last form is called? Vertex form, good. And guess what? We didn't talk about the pros for factor form. Maybe we'll go back to that in a second. But guess what the pro is for when it's written in vertex form? What do you think you can clearly see in that form? In the name. The vertex. All right, so that's going to be the form we're looking at today. And its advantages of that. Real quick though, I forgot to cover why factored form is useful. That one is useful for seeing your x-intercepts, or zeros is what they usually call them. So, for example, x-intercept is when y equals 0, right? So if it equals 0, then that means one of these factors must be 0. So this one I think is easier to look at. What can I plug into this x to make this parenthesis be 0? I'll repeat it. What can I plug into this x that my mouse is on to make this parentheses equal 0? 5. So then one of my x-intercepts, one of my zeros, is going to be 5. And that's how it's written in coordinate form. Guess what the other one is? What can I plug into here to make this parentheses be 0? A 1. So then my other x-intercept is 1, 0. So that's the advantage of factor form. You can clearly see the x-intercept without having to graph them. Same with over here. So what can I plug into this x in the parentheses to make this one 0? -4, good. Because -4 plus 4 is 0. The other one, since that's all that's there, that means I can plug in a 0 into that one. So those are my 2 x-intercepts. All right, that's the advantage of factor form. You can see the x-intercepts without necessarily needing to graph. All right, now let's talk about vertex form. Any questions though before we do that? Okay, so you have a diagram of vertex form. So it looks like this on the right that is on my screen. So if it's in vertex form, that means that it is in this format, like where there's a number inside with the x in parentheses before you square it. There's maybe a constant being added or subtracted on the outside. And the a is still like the a from standard form. It's still the number in front of the x squared, except it's like separated usually. But it's still being multiplied. And the part that shows you the vertex, because that's what we said, that in vertex form, it's really easy to see the vertex. It's going to be your H, so they call it H and K, and your K. Now notice the signs on each of them. The H in the equation is negative. So if my H for the problem is 3, all right, when I plug it into here, it's going to look like this. So we're just plugging it straight into there. But it's still a positive 3 that I've plugged in. Now, say I plug in a -3 for the H. When I plug it into this equation, I get x minus a -3. What happens to that double negative? Becomes a positive. So then, with the h, however it looks in the equation, its sign is actually opposite. For the k, it's the same sign that's in the equation. So that's the only like confusing part there. But otherwise, that's where you pull the vertex out from. So if I look at my last example, so like look at the h of x. Don't say it out loud yet. Think about what the vertex would be. Look for the number in the h position. Look for the number in the k position and put them together. So then, class, what's my vertex of h of x? Okay, positive or -2? Actually negative. Okay, because if I look at my equation, this is my equation for vertex form. H would have to be a -2 if it turned positive in the equation. Does that make sense? Okay, and then what's my K? -4. So H is always opposite of how it looks in the problem. K is always how it looks. That's my vertex of that one. Now think to yourself again, maybe write it down as an example if you want. But for R of X, think about what the vertex is without saying it. All right, so table 3, what do you think the vertex is for R of X? Okay, so they say 3, 4. Anyone agree, disagree? All right, hopefully you agree, because that is right. So the H always has the opposite sign of how it looks in the problem. So if it looks negative here, it's really positive that they plugged into the formula. K always matches. Okay, so then my X of my vertex is 3, my Y of my vertex is 4. Without even graphing, if it's a vertex form, I can see that. So questions on that? All right, again, there's like 3 questions on vertex form on your test. So this is really important. So on your 16 note sheet, we're gonna kind of skip around. On your 16 note sheet, you have a matching thing on the back. You're gonna match the equation with the graph. Now, use whatever strategy you want, but get to the right answer, essentially. There's probably multiple ways you could go about solving it. Get to the right answer, and you'll be A-okay for the test on Tuesday. Since there's like 6 things you need to match, I'll give you 6 minutes. If you're struggling, please let me know. Like for my first hour, we have to stop and do a problem together, but I'm gonna give you a shot right now. All right, so where on the U shape would the vertex be? Well, it depends on what way it's split. So the vertex is if it's this one, it would be where? The bottom. And then if it's this one, it would be where? The top. So it's the turning point of the graph is what we mean by vertex. Or it could be the highest part of your graph or the lowest part of your graph, depending on where it's split. So when we were matching the vertex or getting the vertex from the formula, then we're matching it to the right graph. Granted, and this will happen on your test too, there might be 1 or 2 options that have the same vertex. So then you might have to do a little more work to see like which graph it is. Okay, so I'll let you try and figure it out, and then I'll give you a few more strategies to use, when we go over it. I'll alternate between tables, but you know, if you say I don't know, I'll just kind of ask you more questions to lead you there. So it doesn't get you off the hook, because it tells me that I need to give you a little bit more to do that. I won't necessarily assign a reporter today, but I will if like no one's participating. So just, you guys got this. Shouldn't need to assign a reporter like every single day. All right, but table 2, we'll start with you. For f of x, what graph matches with f of x? Okay, we say f. Let's see. Table 3, what's my vertex for f of x? 1. What was the first number you said? 1. Okay, +1, +4. Everyone agree? All right, you should, because we said the h is always in the parentheses with the x. If sometimes you do have problems that maybe there's nothing in the parentheses with the x, well, in that case, h would be 0. All right, but otherwise, h is in the parentheses with the x. K is outside, and h always has opposite sign of how it looks in the problem. K always has the same sign. So then when we look at all our options, another thing you could look at to like process of eliminate is if A is negative or not. Okay, I don't know if you remember lesson 12 when we did it, but what happens if A is negative? That number in front of the x squared. All right, let's see then. This is also something you can do on your test if you forget that. Since you know the most basic quadratic is x squared, you could play around with it some. You could see what happens if A is negative. What does it do? It flips the graph. It makes it open downward. So then when I'm looking at my matching or seeing what graph matches, if I have some that are on the same vertex, but maybe they're flipped different ways, then I know like I can narrow down my options that way. So in f of x, the A is positive, right? So my choices are all of these except for like C and D. So those open anyway. Find where it's 1, 4. If it's the vertex, it would be the turning point. So it can't be B, can't be E, can't be A. Only one that it can be is F. So that is correct. Questions on that? All right, so the F1 goes with the F of X. Table 4. What does my G of X graph go with? C. Anyone disagree with that? All right, then let's see. Table 5, what's my vertex for G of X? 4, 1. Okay, good. So again, it should look opposite of how it looks in the formula for the H. So that's right. And then K should match with the sign. Now let's see. For this one, will the graph open upward or downward for G of X? Downward, because we have a negative for the A. All right, so that means really I'm looking between 2 options. These are the only ones that open downward. The only one that has the right vertex is C. So yeah, G of X is C. All right, table 6. Which one does H of X match? Did you say B as in boy? Okay, so let's see. Class, what's the vertex for this one? -1, -4, good, that is correct. It should be opposite for the H, same for the K. Look at all the graphs that open, well, that have a vertex of -1, -4. So we have one there. Not one here. Not one here. And we have, look, another graph that has a -1, -4 vertex. So between B and D, which one is it? B, because it opens upward. When my A is positive, so A is positive, it opens upward. When A is negative, it opens downward. So yes, that is B. That's how you can narrow it down. All right, say you have two of the same vertices on two of your options, and then they both flip the same way. So that's what I was telling you earlier would happen on your test. In that case, what you can do, because I think even playing around with Desmos might not be that helpful. I think the best way to figure it out if you're really close between two options is to make a table. So if it's my vertex, since that's the middle of my U, I would put that like toward the middle of my table. And the X's you can always pick. So like I would probably want numbers around my middle, around my vertex. So what are some X values near -1? What are some numbers near -1? -2, what else? 0, what else? Did you say -4? Oh, -3, and then one more, maybe the other way. So by picking numbers around your vertex, you would just plug in these X's into your given equation, get your Y's. So like if I was plugging it into H of X, anytime you plug stuff in, put it in parentheses. But this you could put all in your calculator and get the Y value. I think it's easy enough to do that again, so I'll just do it real quick. What's -3 plus 1? What's -2 squared? Not negative, you should never square something and get a negative. And then what's 4 minus 4?
0.
And then if you're doing it right, they should start to kind of mirror each other. So like if I plugged in 1 into here for the X, 1 plus 1 is 2 squared is 4 minus 4 is, okay, good. What about when we plug in the -2? So -2 plus 1 is -2 plus 1 is -1. -1 squared is 1 minus 4 is -3. And then when you do this one, it should be the same too. 0 plus 1 is 1. 1 squared is 1 minus 4 is -3. So then if it were me and I was stuck between two options, I would see which one has all of these points. Which this one would for H of X would be B. Right? Questions on that? So that's just another strategy that would be helpful on your test. Okay, if you can solve it just from looking at the vertex alone, great. All right, table 7. Which one matches with P of X? D. All right, let's see. It's the only one that opens downward that we haven't matched yet. So just on that alone, that works. Vertex for that one, if you're taking notes, is -1, -4. Oops, almost tripped. Whew. Okay. Table 8, which one matches with Q of X? A as in apple.
Yeah.
All right, let's see, what's the vertex for Q of X class? Good, both positive for this one. So H is always opposite sign, K is the same. This one does have a vertex at 4, 1. Let me check the other one. That one doesn't, so it has to be A. And then by process of elimination, R of X must be E. And let's see if that makes sense with my vertex for R of X. -4, -1. And yeah, that one does have a vertex there, so that makes sense. So do you think on your test, you can confidently match the graph based on vertex form? Okay, good. What if you like completely forget what to do? What could you do to check your answer? Desmos. I try not to have you guys use that as a starting point, because sometimes the answers look really similar anyway, so make a table as a strategy. Questions at all? All right, we're almost done, don't worry. One other pro of using vertex form, so we're probably gonna go back to the 15 paper for this, is you can see the transformations. So transformation, and I'll just put it next to this, kind of make like a little cheat sheet. Transformations are when something transforms, like when something moves. When we're talking about transformations, we're going to talk about transformations of the parent graph. So do you guys remember what the parent graph is? What's the most simple quadratic function I could have? X squared, good. So anything that is done to that X squared graph, you can really see in vertex form. So that's another pro of it. I think you have like 2 questions about that on your test. So let's show you in Desmos. I think that's easy. So here's my parent graph, X squared. We already talked about, let me move it 1 down actually. We already talked about like what happens if A is negative, what happens to the graph? It flips. So you could write that, we talked about it before, but you know, why not just throw it in there? Because A is still part of vertex form, it goes in front of the X. So if A is negative, the graph flips or opens downward from the parent graph. Now, what happens if we change A to a number, something other than 1? Like, give me an example of something other than 1. Okay, so say I put in 2x squared. How does that change the graph? Okay, it becomes skinnier, more narrow. Math words that like the test will use for that is that it stretches. So I would write this down too. If my absolute value of A is greater than 1, then the graph stretches. And when I say absolute value, here's what I mean. So even if I make this a -2, will the graph still be more narrow? Let's see. Yeah, it's still more narrow. The negative makes it flip, but it's the fact that this absolute value is 2 that makes it more narrow. Does that make sense? Okay. So then, yeah, if the absolute value of A is greater than 1, it stretches. So what do you think happens if the absolute value of A is less than 1? What happens? It would get wider. Someone says it shrinks. The math word that you'll see on your test is compressive. Like imagine you're like smushing it until it has to get wider. Like when you edit a picture and you make it like you bring the top down, it makes whatever's in the picture look wider. So also known as compressing. So give me an example of something that's absolute value would be smaller than 1. Well, 0 would actually make the graph go away, right? Because 0 times x squared is 0.
1.1.
Well, -1 just flips the graph. It doesn't get any wider or narrow. Okay, 0.5. So that's like what we need, like between 0 and 1. And if it's negative, all that changes is that it flips. Okay, it's still a little bit wider, if that makes sense. And again, if on a test you forget all of this, play around with the parent graph, which is x squared, and do stuff to it and see like what happens to the graph. But if it's getting wider, it's compressing. Questions so far? Okay, so now here's the cool stuff with like the h and the k. The h is always where in the problem? In parentheses with the x, right? And the squared would be outside parentheses. So give me an example for plugging in for h. Like a number, just give me a number. 4. Okay, 4. Say that we plug in a positive 4 for the h. The way that it'll look is -4, right? Because it always looks different in the equation, but h is plugged in as a positive 4. What happened to the graph? Where did it move? To the right, because we always go from the parent graph to the transformed graph. So if I have a positive h, all right, positive h, then the graph moves in what direction? To the right h units. Okay, so like for example, this one moved 4 units, and you can really tell by comparing the vertex to the right. And also put this little example in there because I know that h gets confusing. So for example, if h equals 4, it looks like this in the problem. It moves 4 to the right. Okay. So then if h is negative, so we plug in a negative number, what way do you think it'll move? Good. Graph moves left h units. I meant to put for this one, graph moves right. Over here. So if you plug in a negative for the h, so now we're gonna plug in a -4. Well, that makes this a double negative, right? Which then makes it look positive. So I plugged in a -4. And it did move to the left, 4 units. So then also put this example, because I know h is confusing. So if h is a -4, that means it looks like x plus 4 in the problem, but it means it moves to the left. Question? All right. Now let's talk about the k. Where is the k located in the problem? Outside parentheses. So sometimes we don't even have parentheses at all. Maybe the h is 0. But give me an example of a k value. Okay, 4, so say we have +4 outside parentheses. Sorry, I need to press the button. Okay, what happened to the graph? What way did it move? So if it's a positive K, it moves up K units. So if K is 4, that means it moves up 4. Guess what happens if K is negative? It moves down K units. And I like that one because it reminds me of the y-intercept, which it is. It affects the y-intercept. All right, so then of course, if you want to see just for fun, if I make that negative, now it moved down from the parent graph. Questions, comments, concerns? All right, so you have these two problems printed on your paper, right? Maybe above this somewhere. Okay. H of x equals x plus 2 squared minus 4. You don't have that somewhere? This would be on the 15 paper. Okay, let me see then. Because I want you to have some examples for your notes. Okay, so how about we look on the back of 15 where there's that table? All right, so these are all in Vertex form. Agree with me? Okay, so we are going to describe instead of just if it opens up or down. Let's just talk about the transformation, because that's a great test question where they give you the equation in Vertex form, and then they say, how did this graph transform from the parent graph? So looking at it, is the A any different from the parent graph for this first one? Y equals parentheses x plus 10 squared. What's the A for this one? It's 1. Is that any different from the parent graph? No, so it's not getting wider, it's not getting stretched, compressed, it's not flipping because it's also not even a negative. So then keep going. The H, there's definitely an H because there's something in parentheses with the X. So if it looks plus in the problem, then what must H be? It must be a -10. So then if it's a -10, did it move left or right? And how many units? Left 10 units. Did it move up or down at all? No, because there's no K. That would have been the Y of your vertex. So it didn't move up or down at all. All it did was move left 10 units. Do you think you could do that for, you don't have to do all of these, but like the ones with numbers? All right, so list the transformation. Let's do one more together. Which one was hard?
The one with.
This one? Yeah. Okay, so what's my vertex for this one? Remember, vertex is H, comma K. Does it have an H?
No.
No, because there's no parentheses with the X. So that means H must be 0. What's my K? -7. And I know that's my K because it's outside of the X squared, not with the X. So yeah, that's my vertex. So it didn't get stretched, compressed, or flipped, because A is still 1. It didn't move left or right, because H is 0, but it did move in what direction? Based on the K? Down, how many units? Down just 7, so yes, because the negative is the down part. Question? Okay, so try the rest of the transformations. Also, you could put the vertex on there too. That helps with the H and the K. But try filling that out. We'll go over it. When you finish, you can work on your puzzle piece. I did not give you 2 separate ones. I combined it. So you can work on your puzzle piece for 15 and 16. I combined it. So yeah, fill this in. We'll go over it in about 4 minutes. So what transformations happened on the second row? Okay, right 4, up 8. Anyone disagree? Okay, the H I know is always like the hard one. What I think about it as is this is the normal equation for it. If it looks right, meaning like it has a negative for the H, then it moves to the right. That's how I think of it. If it has a plus, when it's supposed to be a minus, then it must have been moved to the left. Okay, I know it's weird, but that's like how I think of it. So this is right. Questions on that one? What about the third row? Right 4, up 8. Anything else? There's one more, because if the A is 1, then there's no change for that, but now it's a -1, so what does that mean? It opens downward, so it's reflected. That flips it. So 3 transformations there. If you have an A, an H, and a K that are all different from the parent function, then there's 3 transformations. All right, this row down here, what's going on in that one? What does the 1/2 do to the graph? So when A is, so don't worry about, it's not negative, so it's still going upward. But when A is something other than 1, that means the graph is either stretching or compressing. So if it's 1/2, is it stretching or compressing? It's compressing. Usually they say by a factor of whatever that number is. So you would say compresses by a factor of 1/2. I think this one on the test just says compresses or stretches. So it definitely compresses because the A is smaller than 1. But it's still not negative, so it still opens upward. If it's +3, does it move left or right? It moves left. Because that means I would have had to plug in a -3 for the H, which then means that it became plus in the problem, it really actually moves left. And you can plug it into Desmos to check your answers. What about if it's -5 for the K? Moves up or down? It moves down 5. Good, getting the hang of it, maybe? All right, this row, if it's negative, what does that do to the graph for the A? Good, so it reflects. It doesn't stretch or compress because the absolute value is still 1, so no stretching or compressing in that one. What about if it's +100 for the H, like with the S? Does it move left or right? Left. 100. I know, H is the hard one. I think if it looks right, meaning it looks negative, it moves to the right. If it looks wrong, meaning it looks positive, it moves to the left. Or just plug it in your Desmos and see. And then what about if it's plus 50 for the K? Is it moving up or down? 50. The questions on that? When in doubt, you can use Desmos. I don't necessarily want you to use it like as a starting point. You need to like know this too. But it's great to check your answers. So you still have time, don't pack up till 10:29, work on your practice, ask me questions. But tomorrow you'll have lots of time to work on your study guides to make sure you're ready for Tuesday for the unit test.